Chances are you've seen the sun shine brightly in the sky, or watched a bolt of lightning strike the earth during a thunderstorm, or raised and lowered a window shade. Do you know what all these things have in common? They all involve energy. Energy is all around us and is involved in almost everything we do. We use energy when we eat, when we run, and even when we breathe. Energy is defined as the ability to do work. Every time we do work, we use energy. When playing sports, we use a lot of energy, and we're often tired when we're finished. We're working all the time. When we pick up a heavy object, we exert a force over a distance to move the object. We're doing work. An object may gain energy as well. When we throw something, we're giving the object energy to travel and move. Energy comes in many different forms, but there are 5 main forms which are commonly used in everyday life. During the next few minutes, we're going to study the different forms of energy and the role energy plays in our lives. You decide. What do the following things have in common? These cars, this skier, and this stream. They're all in motion. When an object is in motion, it has energy. Energy associated with motion is called mechanical energy. The legs of these animals exhibit mechanical energy, enabling them to walk. Waves moving in the ocean also exhibit mechanical energy. Most machines use mechanical energy to get certain jobs done. The mechanical energy of objects that are in motion is also referred to as kinetic energy. Kinetic energy is the energy of motion. We'll discuss kinetic energy in a few minutes. Nuclear energy is another form of energy. The star that lights up our days, our sun, produces nuclear energy. Nuclear energy is energy trapped in an atom. This is a model of an atom. The nucleus is at the center of an atom. This is where nuclear energy is stored. The type of nuclear energy that occurs in the sun is called fusion, which is the result of the joining of nuclei of 2 hydrogen atoms. Nuclear energy may also be released when the nucleus of an atom splits apart. Fission is the process of splitting the nucleus of an atom into smaller nuclei. When the nucleus splits apart, a great deal of heat energy is released. In nuclear power plants such as this one, the heat from the splitting atoms is used to heat water to create steam. The steam is used to spin large turbines to generate electricity. Have you ever rubbed your hands together on a cold winter day? When you rub your hands together, the friction between your hands causes mechanical energy to convert to a third form of energy, heat energy. All matter is composed of atoms, tiny particles that remain in constant motion. Heat energy is associated with the motion of these particles. When the motion of these particles increases, the amount of heat energy they produce also increases. Heat energy is responsible for changes both in temperature and in phases of matter. As you probably already know, it's possible to measure the temperature of objects with a thermometer. Ice has less heat energy and therefore has a relatively low temperature of 0 degrees centigrade or less, whereas this cup of hot water has more heat energy and has a temperature between 60 and 70 degrees centigrade. Heat energy is also responsible for phase changes. A phase change involves matter changing from one phase to another. For example, water can exist in the form of solid ice. But when ice is heated, it changes to a liquid. And if liquid water is heated even further, it changes to a gas. As we've already learned, matter is composed of tiny particles called atoms. Bonds like these between atoms make it possible for substances to form and hold their structure. Within each of these bonds is a certain amount of energy. The energy within the bonds that holds atoms together is called chemical energy. When wood is burned, chemical energy is released and converted into heat energy. Fuels such as gasoline and diesel fuel also contain chemical energy that, when combusted, propel machinery. We use large amounts of chemical energy every day. When we digest food, the bonds between atoms are broken, releasing chemical energy. When we walk down the sidewalk, we use the stored chemical energy that we've gained from food. You decide. What causes this bulb to give off light? It's lit by electricity flowing through the thin piece of metal in the bulb. The energy associated with moving electrical charges, such as in the light bulb, is called electromagnetic energy. All matter is composed of atoms. But did you know that atoms are composed of many smaller types of particles, one of which is called an electron? The small particles orbiting the nucleus are electrons. Electrons carry an electric charge. When these particles move through materials that conduct electricity, such as the metal in the light bulb, it's converted to light and heat. Electromagnetic energy is all around us, and we use it every day. It's carried through power lines in the form of electricity. It's used every time we turn on a computer, and it's even in lightning. What do this hammer, this spatula, and this shovel all have in common? These three objects are all doing work on a second object. The hammer is forcing the nail into the wood. The spatula is flipping over the egg. And the shovel is lifting the rock. Since these objects can do work, they have energy. And since the objects are in motion, this energy is called kinetic energy. Kinetic energy is defined as the energy of motion. You decide. Which has more kinetic energy, this ping pong ball or this baseball? That's right, the baseball has the most kinetic energy. The amount of kinetic energy an object has is directly related to both its mass and its velocity. Would you rather be hit by a ping pong ball tossed towards you lightly, or by a fast-moving baseball? Of course, you'd rather be hit by the lightly tossed ping pong ball. That's because it has less kinetic energy. Have you ever sat at the top of a slide or prepared to bike down a hill? If so, you've experienced potential energy. Potential energy is stored energy. It's also referred to as the energy of position. When you're at the top of a slide, your body has stored energy waiting to be released when you go down the slide. This stretched rubber band has potential energy, and when released is flung outward. Potential energy also exists in foods. Food contains stored chemical energy, which is released upon digestion. Any object above the Earth's surface has gravitational potential energy. This bridge has gravitational potential energy, as does this apple. We've already learned that there are 5 main forms of energy. But did you know that these forms of energy are interchangeable? Energy is able to be converted into many different forms. When you rub your hands together, mechanical energy is converted into heat energy. And when you light a match, an energy conversion occurs. When the match head is rubbed against the box, mechanical energy changes to heat energy. The heat energy causes the chemicals in the match head to ignite. Chemical energy is then converted to heat energy that we can feel and light energy that we can see. Energy can also be converted from potential energy to kinetic energy, and vice versa. Almost everything in this world can be created or destroyed. Can you think of one thing that cannot? Energy. The law of conservation of energy states that energy cannot be created or destroyed, only changed in form. Take a light bulb, for example. Have you ever noticed that a light bulb gets very hot when you turn it on? This heat energy is formed from excess electromagnetic energy, which was not converted into light energy. No energy was lost, it simply changed form. During the past few minutes, we identified the 5 different forms of energy, including mechanical, nuclear, heat, chemical, and electromagnetic energy. We investigated kinetic energy and the factors it depends on, mass and velocity. We studied potential energy, as well as gravitational potential energy. We also took a quick look at energy conversions and explained the law of conservation of energy. So the next time you flip on a light, eat a piece of food, or go for a run, take a minute to think about how energy is involved in your life. You might just think of energy a little bit differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. Energy is the ability to do. Number 2. Energy is energy associated with motion. Number 3. Energy exists in the bonds that hold atoms together. Number 4. Electricity is an example of energy. Number 5. Energy associated with the motion of atoms in matter is called energy.